Hello, friends of chemistry. Martin and I are videoing on your own 12.5. Let's hear it, smarty man.
So, oxygen. So,
read the problem.
Yeah, I know. I'm getting into that. A tank of compressed air contains 672.0 grams of oxygen.
Now, what is oxygen?
Diatomic.
It's a homonuclear diatomic, so it's O2. Okay.
2,184.0 grams of nitrogen.
Also a homonuclear diatomic.
And 40.0 grams of argon, not a homonuclear diatomic.
What is the chemical symbol for argon? I believe it's AR.
Yes, you're right.
Okay.
Argon is 39.9.
We'll get to that in a moment. So keep reading.
Oh yeah.
What
is the mole fraction of each component in this mixture?
Okay. So let's look on page 399 where they explain to us what is a mole fraction. The mole fraction is
moles
the number
of component over moles in the mixture. Total moles in the mixture.
The number of moles of the component per the total number of moles. So, unfortunately, they have not given us any molar values. They have given us grams. So we are smarty pants, so we can figure out how many moles each of these is. Then we're going to add those numbers up, so we know the total number of moles, and then we're going to report each as a mole fraction, right?
Yes.
Okay, so let's figure out how many moles of oxygen we have.
16.0 AMU.
Okay, so O2 is 32.0 grams per mole, right?
Yes. No, moles per mole.
Or
mole
one
per
mole
gram, per so many grams.
Per 32.0 grams.
Nitrogen is 14.0.
So that's 28.0 grams in each mole.
Moles.
Okay, and how about argon? What did you say argon was?
39.9.
39.9 grams per mole. Okay, so we're going to multiply all these numbers by these conversion units. So we're going to say 1 mole.
Aren't we dividing these?
We want to know how many moles we have. So we're going to say 1 mole per 30. We want to get the right conversion unit. So yes, you will be dividing. See? Right. But let's set up the right conversion units before we do the math. Before we use the calculator, make sure you have the right things written down. So for the nitrogen, it's 1 mole per what? 28.0 grams. And for the argon, it's 1 mole per 39.9. Okay, so grams will all cancel. So divide 672 by 32. What do you got?
21.
21 exact?
Yes.
Okay, so how many significant digits do we want? We want 3. So we're going to report it's 21.0, right?
Okay.
Moles of oxygen. How about nitrogen?
78 even.
And we want 3 again. So we're going to report 78.0 moles of nitrogen. Okay? And this is very close to 1 mole. Can you see that?
This is 1.00. There's more, but that's...
What comes after the 0?
2506.
So it's 1.0...
0. 1.00.
002. Can I see the number? Thank you. It's 1.0025. So since the 2 isn't big enough for me to round, well, if it was a 9, then I would report it as 1.01. So I'm going to 1.00 moles of argon. Okay. So I'm going to add all these up to find out the total number of moles. What comes in here? My rules of significant digits or my rules of precision?
Precision.
Precision, because I'm adding. So I can only be precise to tenths. This has hundredths, but these only have tenths. So I'm going to say 21 plus 1 is 22, plus 78 is...
It's 100.
It's 100, exactly.
Yes.
And I'm going to report it as 100.0 moles. Okay? So now my oxygen. What do we call the mole fraction? We write it like this. We say the X, the mole fraction of oxygen, okay, of, our element or molecule, right? So the mole fraction of oxygen is 21.1 per 100.0. That really can't be reduced, right?
Yeah, it's 21 per 100 over 100. Or we could put it in decimal numbers like they do in the answer.
Yeah, so
example.
let's do that. How do you write 2100ths?
It's simple.
How many decimals should we have?
2.
We want to have 3 significant digits, right? 1, 2, 3. This has 4, so we want to have 3. So the X of the O2 is 0.21. What's the X of the N2? It's 78.0 per 100.
Yeah.
0.0 or 0.780. Okay, 78 hundredths. And the X of the argon is, of course, 1.00 per 100, which equals 0.00100. Why do I need all those zeros, Martin?
Because
how many significant digits are in that mole fraction answer that I have written on the chalkboard?
3.
Yes. Which ones are they? Go up and draw underneath them which ones they are.
I hope you don't mind squeaking.
I will forgive you in advance.
The
argon.
Right?
Tell me which are here. Move so that people can see it. Which are the significant digits?
So it's like.
There are 3 of them. That's 1, 2, 3. Excellent. These are the 3 significant digits. These are considered insignificant, although they're important for place values. You can either report it like this, or you can say 1.00 times 10 to the negative 3. Okay? Either way is fine. Does this have any units, this mole fraction, Martin?
No.
Correct. It has no units. Okay? What should all of these add up to? If I add all these up.
1.
Yes, that's correct. They will all add up to 1. Okay? Any questions?
No.
Good. Here, stand up for a second. Right behind me. Stand up. Put your arms out. Touch my head.